Now next we have to consider the resolution of vector. What is mean by this resolution of vector? The vector resolution we have to consider. The vector resolution we have to consider what is mean by this vector resolution. The resolution of vector just implies that any vector can be expressed as a sum of multiples of other two vectors. Any arbitrary vector if we are considering, that vector can be expressed as the sum of multiples of any other two vectors. That is the resolution of vector. That becomes the behind or the background principle of this vector resolution. Okay. So in order to consider this resolution of vectors, first we can consider what is mean by this, or how we can resolve this vector or resolution of this vector can carried out. In order to consider this resolution, first we have to consider the two vectors we are considering. One is this vector A, small letter A, we are using the representation, the vector A is considered, and another vector, that is a vector B, is considering. Small letter B is another vector we are considered. Okay. Then along with this A and B, another vector, that is vector capital A, is also considered. These three vectors are existing in a particular plane, in an xy. Suppose we are considering in an xy plane, then these three vectors are there. Okay. Then how we can express this vector A in terms of these vectors A and B. The capital A vector, how we can express in terms of this A and B. For that purpose, just we are considering this the vector capital A. Then from the one end, just as capital A, we can express it as this OP as the vector OP as the capital A. Then from this point O, we have to draw a line parallel to the vector A. From the point O, we have to draw a line parallel to the vector A. Vector A's directions parallel to vector A's direction, we have to draw a line. This is vector A, then parallel to that one, we draw a line from the point O. And similarly, from the point B, we have to draw another line which is parallel to the vector B. Here is the vector B. Then parallel to this vector B, we have to draw a line from the point P. Okay, through the point P, we have to draw a line parallel to P. And now this intersecting point is obtained. Okay. The two lines are drawn and the intersecting point of that line is obtained at this particular point. Okay. Then just if we are considering this OP as the vector A, then now this side is parallel to that vector A, so we can express it as the same direction will be the, so direction is not changing but magnitude sometime may be changed, so we can express it as vector A into any arbitrary value. Let we can consider it as lambda, A lambda. Its magnitude may be changed by a factor lambda but direction remains same, so this side we can express as vector A lambda. Okay. The same way, this side is parallel to vector B, the direction remains the same, and but the magnitude may be changed, so we can express this side similar to vector B. Let another arbitrary constant mu times that vector B. Vector B, that is the same direction as that of vector B, and its magnitude is changed by a factor of mu. Mu may be any arbitrary value, it is 2, 2.5, 1.5, any other value. Here also the lambda's values also may be varied from 2 to 2.5, 1, any other situations we can, any other arbitrary values we can consider. Okay. Then that's why this vector OP, then here if we consider this triangle law of vector addition or parallelogram law of vector addition, we can express this vector A as the vector A can be expressed as the sum of these. It is vector A can be expressed as the sum of these small two vectors a and b, that is vector a can be expressed as, in terms of this vector a, we have to express it as lambda a plus mu b. That is the new representation of this vector. It can be expressed as lambda a plus mu b. That is a representation. That means the vector a can be expressed in terms of other two vectors, vector a and vector b. Vector a equal to lambda times of that vector a plus mu times the vector b. Okay, that is the resolution. That means the vector a can be expressed in terms of other two vectors. That is the resolved components of vector a can be considered as this lambda a and a mu b. Okay, then for the two-dimensional space it is more clearly we can explain. For the two-dimensional space, just we are considering this x and y axis, we can consider its x-axis and y-axis. Then in two-dimensional space we are considering a vector OA is a vector is considered. Okay, then we can construct, applying a parallelogram law or any other thing, we can construct a, or we can construct and extending the lines. That is, from the point A we have to draw a line parallel to this y axis, and from the point A we can draw a parallel line to this x axis. Okay, an intersecting point here, and according to this parallelogram law, suppose this side, this is along this x axis and this is along the y axis, so this vector, this side here we can consider as a vector a1, and here this side we can consider as a vector a2. So according to this, and it is directing along this x axis, so here in order to represent that direction it can be expressed as this unit vector I here you can use, and here we can use this unit vector j cap. Okay, then according to this parallelogram law, this vector a can be expressed as this a1 plus a2. Then a1 means what is, instead of a1 it is what, it is a1 I plus a2 j. So that vector, resultant vector a is expressed as in terms of this x component and this y component. Here a1 is the magnitude of any arbitrary value, the magnitude, and this I represent the direction. Here a2 is the magnitude any arbitrary value, and j represent the direction along this y axis. So this vector a is resolved into its two components. One is along this x axis and the other one is along this y axis. The x axis component is a1x and the y axis component is a2j. That is the resolution of this vector. Okay, then the any vector in this manner, any vector can be resolved into, if it is considered in a two-dimensional space, then any vector can be resolved into its x component and y component. Okay, an x component and y component. If it is in three-dimensional space, then along with this x component and y component, one z axis is there, so a z component will be there. So it is a1 plus a2 plus, along this z axis we can consider it as a3 as the part. Then here becomes along this one a2 plus what, a3 k. A3 component is along z axis, and in order to represent that z direction we are using this unity vector k. Okay, if it is in three-dimensional space, this will becomes, now in this section we are only dealing with the two-dimensional space, so we requires only this x component and this y components. Okay, we are representing the x component and y component only. Okay, that is a resolution of this vector. Okay, vector resolution. Any vector can be expressed into its corresponding x component and a y component. Okay, then if we considering this angle between that vector and the x axis, then it is easy to resolve the components. Suppose the angle in the vector a makes an angle theta with this x axis, then just finding, suppose if we are using the trigonometric ratio cos theta, what becomes cos theta means it is adjacent side divided by the adjacent side divided by hypotenuse is cos theta. And here from this triangle, what is this adjacent side? Adjacent side means that is vector a1 or axi or a1. Ax divided by hypotenuse means that is the resultant vector a, that is cos theta. Then this component, this is the x component, then that x component, how we can explain it as ax equal to, just taking this a to this side, then it becomes what? A cos theta. So if we know a vector and the angle between that one, it is easy to find out that x component is a cos theta. The same manner, if we know the same manner, if we are finding this y component, how we can find the y component? So for that one, we have to consider this sine theta from this one. The sine theta means it is opposite side divided by hypotenuse. Here opposite side means what? Opposite side is this one. This one means that is what? A2. A2 means that is AY divided by hypotenuse means it is vector A. So in order to find this y component, this is AY is the y component, just taking this A to this side, then becomes that y component AY equal to what? It is A sine theta. If you are finding this A sine theta, that gives the y component of that particular vector. Okay. That is, if we know this theta or the angle between the particular vector and the x-axis, then very easily we can find x component of that vector and y component of that vector. In order to find x component, that is ax equal to a cos theta, then y component ay equal to a sin theta. Then if the theta and the magnitude of that vector, if the angle theta and the magnitude of that vector is known, that means the theta value and the magnitude of a are given, then easily we can find this ax, the x component, and also it is easy to find out the y component ay. Ax equal to what? It is a cos theta, ay equal to it is a sin theta. And in another situation, suppose if only the ax and ay, that means the x component and the y component are given, x component of that vector and y component of that vector is given, and we can easily find that vector a, the resultant vector a, and also the angle between that vector we can find. How it is possible? In this situation, suppose in this situation ax value and ay values are given, ax value is given and ay values are given, that is x component and y component values are given, then how we can find this vector a, the resultant vector a is how we can find. The resultant vector a we can easily find by taking that root of that ax square plus ay square, ax square plus ay square, and that gives the resultant vector. How it is obtained? Just applying this Pythagoras theorem from this triangle. Just we are considering this right angle triangle, then applying the Pythagoras theorem. It is, this is resultant vector a, and we know that this a square equal to, this side means what? It is a2 square plus this side a1 square. A square equal to a2 square plus a1 square, so a equal to root of ax square plus ay square. Okay. And if you know the, if you are unknown this theta value, this angle is not known, then how we can find? Just finding the theta. In order to find that theta value, just theta equal to tan inverse of y component of that vector divided by x component of that vector, ay divided by ax, ay divided by ax, tan inverse trigonometry, tan inverse of ay by ax, that gives what? The theta or the angle between these two. That is from this triangle, again we are considering the trigonometry ratio. Suppose if we are finding the tan theta equal to opposite side by adjacent side. Tan theta opposite side means it is ay divided by adjacent means ax. Tan theta equal to ay by ax. Tan theta equal to, the tan theta equal to what? It is ay opposite side divided by ax. Then theta equal to, just taking this tan to this side, then that is tan inverse of ay by ax. That is the equation here you obtained. Okay, that is a way we have to find this theta value and the resultant value if the components are given, And if the resultant vector and the theta is given, then we can easily find out the components, ax component and ay component. Ax equal to a cos theta and ay equal to a sin theta. Suppose if we are using is in this three-dimensional space, if we are using it is in the three-dimensional space, then along this x, y and z, along this x, y, we have to consider the z component also. Okay, then that becomes the resultant vector A becomes a1 plus a2 plus a3, that is a1x axi plus ayj plus azk. Okay, then in that manner we have to consider this three-dimensional space. The next we have to consider the vector addition once again. Only one method of vector addition is mentioned, that is a graphical method. Now we have to consider the analytical method of vector addition, or we can analytically a vector can be added. So suppose two vectors are considered in this vector A and vector B. The vector A and vector B, we already know the general form of this vector. Suppose here we are considering only this xy plane, then x component and y component will be there. So the vector A can be expressed as what? The vector A can be expressed in terms of this x component and y component. That means axi and plus ayj. J is the representation of unity vector, that is representing direction. And similarly the vector B is its x component, it is bxi plus byj. This is a vector A and vector B, then in terms of its x and y component, because here we are considering the xy plane, so x component and y component we have to consider for both this vector A and B. And in this analytical method, how we can add this one? So adding of these vectors A and B means just adding the x components together and the y components together. That means if you want to add this vector A and vector B, just adding these x components together and these y components together. That means just addition of this vector means in analytical method how we can add this one, just adding the components, that is a resultant vector. Suppose that it is a resultant vector, so we can represent as r, that is equal to x component. The x component of the first vector is ax, then I is the, then plus I is common for this x component, so ax plus bx then into I. This represents the x component of the resultant vector ax plus bx. Adding the x component of that individual vectors, that gives x component of the resultant vector, plus then adding the y component, that is ay plus by into j. That gives the, this gives the y component or y coordinate of the resultant vector r. X component A plus y component, then in order to represent the direction of that one, unit vector I for that x axis and unit vector j for representing the y direction. Okay, this is a proper method of this analytical method of vector addition. If any two individual vectors are given, then analytical method addition means just adding the x components together and represent the direction, then adding the y components together and using the representation of that y direction. That is ax plus bx into I plus ay plus by into j. That is the resultant vector, vector A plus B. Okay. And suppose if we are using it as a three-dimensional space, then what becomes? If it is if we are using a three-dimensional vector, then what happens? Along with this one x and y component, one more component will be there. What is that? It is a z into unit vector k. Similarly for this vector B also, it is bz into unit vector k is there. Then addition means x components are adding together, that is ax plus bx into I plus y components are added ay plus by into j. Then one more term we have to add, that is what? Plus this z component. What is that? It is az plus bz into k. Az plus bz into k is the representation used for this z component. Okay, az plus bz into k, that is in three-dimensional space. Most of the situations in this motion and plane chapter, we are dealing with the two-dimensional space x and y. So we are the x component we have to add this x component together, ax plus bx, then y component together, ay plus by, then representation with the help of that unit vector I and j. That is the analytical method of vector addition. Okay, in this section just we are considering what is, first we consider this term, the position vector. We are considered the position vector. Then after that the displacement vector. We mentioned about the position vector, then displacement vector. First we consider the position vector. In order to represent the position of an object with respect to a common origin, we are using this position vector. Then after that we consider the displacement vector. Displacement vector means if you know the position vector, initial position and a final position if you are known, then the components of that final position minus components of initial position, that gives the displacement vector. Okay, it is directed from initial position to final position. And after that we consider the addition and subtraction of vector. Addition and subtraction of vector. In the addition and subtraction of vector, the subtraction is also can be carried out with the help of that addition. How? Just adding the negative vector of that one. Then addition of vectors, commonly we are using, one is the graphical method and the other one is analytical method. Okay, graphical method and the analytical method. In graphical method we mention about the triangle law of vector addition, then parallelogram law of vector addition, then polygon law of vector addition. All these three are we mentioned in triangle law. Just arranging that vectors, head of one vector is arranged with the tail of the other one, then joining the free ends, that gives the resultant of that vector. And in parallelogram, just join that vector to a common point, then construct a parallelogram by drawing a parallel lines to each side, then intersecting point will be obtained. Common point is joined with that intersection and that gives the resultant vector. Then polygon law means if more than two vectors are there, just arranging that vectors in the form of a polygon by joining the head and tails, then the remaining part is joined, that remaining part will give the resultant vector. Okay. Then in analytical method we have to use the components of that one. Any vector can be expressed into in its xy component if it is in two-dimensional space, can be expressed in xyz components if it is in three-dimensional space. So if the xy components are available, then all the x components are added together, then all the y components are added together, and that gives the x component of the resultant vector, and all the y terms are added together, that gives the resultant y component of that resultant vector. Along with that one, we consider the resolution of vector. That means any vector can be resolved into its two components, x component and y component, in two-dimensional space. Can be resolved into three components if it is considered in three-dimensional space, x component, y component and z component. How it is resolved means, if we know the resultant vector and the angle it is made with that x-axis, then we can easily find out the x component and y component. The x component ax we can obtain as ax can be obtained by just knowing this angle and the resultant vector. Then the x component ax equal to what it is, ax equal to a cos theta, and the y component ay equal to a sin theta. This is a method to easily we can find the x component of a vector and y component of a vector, resolving into any vector can be resolved. If we consider any vector in a two-dimensional space, that can be resolved into this x component and a y component. Okay, that's about this section. Okay, thank you.